Cool, brand new chapter. Today is theoretical probability. That's a cool word because it doesn't work that way every single time. This probability stuff, but in theory it would. You know, the math says this is how it should turn out, and in real life sometimes things dictate differently. But here's what you really do. It's just what you want to have happen divided by total. If I said, what's the probability of pulling your name out of a hat? If all of your names are in the hat, you know, that would be like the total number, right? And isn't your name in there once, you know, you would have 1 out of, say, 20 or however many people are in here in that case. So there's some cool little vocab words here also. Events and outcomes. The result of an experiment is called an outcome. So right here, if I roll this dice, that outcome was a 4 because it landed on a 4, right? That was the outcome of that event. An event is just a particular outcome or group of outcomes. And then there's this simple event. It's something that can't be broken down further. And then the sample space. Big deal. Let's just kind of dive into these questions. If we roll a normal 6-sided die, describe the sample space. The sample space is all things that are possible. So if I roll this, what is possible? A 1, 2, 3, 4, 5, or 6. Are you with me on that? That is like the sample space. All the possible outcomes. If it was a 7-sided die, it'd go up to 7. You know, it's just that's how many sides it had. 6 sides, 6 outcomes. A simple event is like just an event that can't be broken down further. So here's a couple examples. Like if I roll this dice and roll a 3, that's it. That's the entire event right there. There's nothing more that can happen. So like rolling a 3 or rolling a 5, it's just a real simple event. But a compound event is if I said, hey, what's the chances I roll this dice and maybe I roll an even number? Because would you believe there's more than one possible way to do that? I could roll a 2. I could roll a 4, or I could roll a 6. Are you with me? Like, that has possible outcomes. So it's just an example of rolling an even number. That's a compound event. Then here they ask us to, like, just find some probabilities. So when they ask us to do that in math talk, they put, like, a capital P out there for probabilities. Like, say, if we roll a 6-sided die, calculate the probability of rolling a 1. Here's what I like to do. On paper, I'm going to make a fraction. Sometimes homework will want a fraction. Sometimes it'll want a decimal. So here's what we do. If we just do a little want over total, that's how it works. Want over total. They say, what's the probability of rolling a 1? Would you believe we want a 1 to show up? How many different ways could that happen on a 6-sided die? How many 1s are there? There is just 1, right? There is one way to roll a 1. How many total possible outcomes were there? 6. Are you with me on that? You have a 1 out of 6 probability to roll a 1 on a dice. Does that kind of make sense? And if they want us to change that to a change that to a decimal, you just have to read homework. Do they want it as a fraction or they want it as a decimal? Most of them want them as fractions. Are you with me on that? So 1/6 would be the answer to that. What is the probability of rolling a number bigger than 4? Well, here's our sample size. If we do 1 over total, you know, we know there's a total of 6 possibilities rolling a dice. How many of them are bigger than 4? Well, here we go. How about 6? Isn't 6, that's not a highlighter, Mr. Fauna still. Isn't 6 bigger than 4? And 5 is bigger than 4? The question is 4 bigger than 4? So 4 doesn't count. Would you believe there were 2 ways to do that? You could have rolled a 5 or you could have rolled a 6 out of 6. We will reduce that. If you have one of my calculators, here's how you like clean up the fractions, because they'll come out nastier than 2 over 6. But if you type 2 over 6, it'll give you a decimal. And then if you hit math, enter, enter. We'll do much more of that today, but that would reduce that to 1/3 for you. And that's what they'll want when you put a fraction in. They'll want it to be reduced. We'll let the calculator do all the reducing for us, though. You cool with a die, right? That's just one die today, 6 possible sides on a standard guy. What I used to have is coffee cans like this full of Starbursts. In a different class, we have some Starburst hand grabs and stuff, and then I got hooked on Starburst and started eating them like all class period long, all day, and I said, no more Starburst for me underneath the podium. But I don't know if you remember at the beginning of the year, I was just mowing down Starburst like it was going out of style, and got a little fat on that. But you know what I mean? Like, I got a coffee can right here, and it could have Starbursts inside of it, right? There's different colors of Starburst. In this particular coffee can, 13 yellow Starbursts, 8 pinks, which a lot of people, that's their favorite, is the pinks, 12 reds, and 9 orange starbursts in the can. What is the probability of me reaching in there and randomly picking out these things? Here's what we need to know first. How many total starbursts are in there, right? How would we find total starbursts? Let's add them up. So grab your calculator and add those bad boys up. 13 plus 8 plus 12. What was the last one? 9 plus 9. Are there 42 starbursts in this imaginary coffee can right here? So I think it's handy to write that down. You know, we had a total of 42. What is the probability that if they were like mixed up randomly and all that junk, that I reached in, didn't look at it, and pulled one out and it was yellow? Well, that's just want over total again. Want over total. I want a yellow one. How many yellow ones were in the can? 13. Out of? How many possible were there? Total? 42. They, on homework, on this particular type of question, say round to 4 decimal places. So even though 13 over 42 might be the reduced fraction, they won't accept it. They want it as a decimal because they literally said put it as a decimal. So there we go. That's a nasty boy. So they say round that to 4 decimal places. So that would be 1, 2, 3, 4 is what they want. But you have to look to the 5th one to see if this number rounds up or not. So what do you want to do? Keep the 5 the same or round them up. Keep it. So 0.3095. 0.309. That's how they want it as a decimal. Many students are like, what does that even mean? If you changed it to a percent, which we'll have to do a little bit later, remember like moving the decimal 2 places to the right, would you believe that's a 30.95% chance of me pulling out a yellow starburst in that situation? So that's kind of what it means. Cool. What if they said, what's the probability of pulling out a pink or an orange? Make a note for yourself because the chapter will get a little more complicated as we go. Or means and. Or means add. Or means add those things together. So if they want you to pull out a pink one or an orange one, we need to add up all the pinks and the oranges. There are 8 pink starbursts and 9 orange starbursts. If we add those together, how do you feel about that being 17 starbursts total, right? 8 of them were pink and 9 of them were orange out of the 42 total starbursts. So they want it as a decimal, so 17 divided by 42. We'll round that to 4 decimal places. 0.404. Do you see how that 7 needs to round up to become an 8 in that case? So 0.4048. Basically a 40% chance of me pulling out a pink one or an orange one. But then the one that makes people scratch their heads, what's the probability of me pulling out a green starburst from there? Are there any green starbursts in the jar? No. So that is like 0 out of 42, which is a 0% chance, right? It is not possible to do that because they were not inside of there. Coolio? All right, so that's just basic probability right there. Let's say you have a bag with 20 cherries, 14 sweet and 6 sour. So they told you the total right here. If you pick a cherry at random, what is the probability that it will be sweet? So when you do want over total, you want a sweet one. There are 14 sweet ones, and there are 20 total. I would like this to be a fraction. If they don't say make it a decimal, they would probably want you to leave it a fraction. So if you have one of these calculators, you do 14 divided by 20. And then if you hit math, enter, enter, right? So there's this math button right here, the math button, and then just hit enter twice. Or if you can reduce fractions, you know, it's like, oh, that's just 7 over 10, you know, it's all good in the neighborhood. If I hit math, enter, enter, that would be better. So 7/10 chance that that would be sweet. I would like to talk about why this is theoretical probability, though. In theory, that is true. In real life, that could be very wrong, because what if in here there were those 20 cherries, the 16 sweet ones were on the bottom, and the 6 sour ones were on the top, and I just reach off the top and pull it? Would you believe that the percent changes drastically because it wasn't mixed up? Do you know what I'm saying? It wasn't randomized. So in theory, everything's like fair, and they mix it all up real well. But you could rig it to where it's more likely to pull out a certain type of cherry if you wanted to. Do you know what I'm saying? That's why people say, shake them up, shake them up. Let's do that. So, cool. Here is a big chart right here. Given a test to a group of students, the grades and gender are summarized above. If one student was chosen at random, what is this? What the heck do you think that means? What does this P stand for out in front? Probability of a B. Like, see, they're giving grades on the test. You either got an A, B, or a C in that case. The cool thing about the chart is they tell us all the totals. Do we know how many total students there were? What do you think? There's a lot of totals down there. Which one's the total students, though? You said which one? How do you guys feel about that? Is that the total number of students? Yes, 65. And then we want to know how many people got a B. So even though we got some people who were male and female and all that stuff, isn't there 14 people that actually got a B total in that case? So 14 out of 65. 14 divided by 65. They'll leave it as a fraction, but I want to see if it reduces, so I just punched it in, you change it to a decimal, and then you hit math, enter, enter, and that did not reduce. It just stayed 14 over 65. Cool, which is basically a 21.5% chance of that happening. And then the last one is the one that is intimidating to a lot of people, cards, because many people have not played cards. You'll see on cards questions, I have put this picture on every homework question for those who do not understand how cards work. They're like, I don't know how many cards there are. There is clubs. You see those on top. There's 13 of those, right? It goes ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Usually I like to put the ace at the end because I think ace should be high, but some people call ace high or low. But you realize there's 13 here. There's 13 spades. There's 13 hearts and 13 diamonds. That is a total of 52 cards, right? Sometimes there are jokers in the deck also. They usually don't talk about them. They'll mention them specifically if the jokers are in the deck. So we'll just have these. It says, so if I do 1 over total, how do you feel about 52 is the total number of cards so far, right? They say, what is the probability of drawing 1 card from the deck and getting an ace? How many aces are in the deck? 1, 2, 3, 4, right? There is an ace of spades, an ace of clubs, an ace of hearts, and an ace of diamonds, so 4 out of 52. And if we punch that in, clear, 4 divided by 52, and hit enter, and then if you do math, enter, enter, that will change that to 1/13 chance. You have a 1 out of 13 chance. I want to add a couple more questions just because it was a short lesson. What's the probability of me pulling out a heart? How many hearts are in the deck? 13 out of 52. Are you with me on that? Which you can reduce that. That would be 1/4 chance in that. And then they might mention something that some people don't know about, a face card. Face cards, you see everything from here to here does not have a human face on it. Are you with me on that? But the jack, that is like a person, back in the old days, has a human face, human face, human face. You see all of these have faces on them. So the face cards are the jacks, the queens, and the kings. Cool? What is misunderstood is people think aces are a face card. They are not, because they do not have a human face on them. Rock on? Cool. Let's rock some homework. That could be.